Haskell is covered with myths and stereotypes, such as you need PhD to write Haskell, or Haskell is only good for writing compilers. This is silly and not true. So let's debunk the most common ones. I want to cover the 4 main categories of stereotypes, which can be expanded into another set of myths. Haskell is only for academics. You can't do anything useful because there are no side effects. The Haskell tooling is very bad. Haskell has an ivory-tower community. Let's start with Haskell is only for academics. Yes, academics use Haskell and it's very nice for them. But no, you don't need a PhD to use Haskell. It's like saying that Go is only for Google or Alphabet developers. This meme has 2 sides. Haskell is only for academics. It's no good for industrial use. And Haskell is too difficult and complex to learn. First, Haskell is used in many production systems. Check out this list with some companies that use Haskell in production. Companies such as Facebook, NASA, Verizon, etc. Second, Haskell can be hard to learn. But programming is hard. Learning programming for the first time is hard. If you have years of experience, you've probably picked up multiple languages, and when you try to learn a new language such as Go, Rust or Kotlin, it feels familiar. Of course, there are some new and different ideas, but you're not starting from scratch. When you try Haskell, it can feel alien. There is a bunch of new things all at once. Haskell syntax and concepts can take some time to understand, but once you do, you're gonna have a whole new and powerful toolbox available to you. And then picking languages like PureScript, Elm and others are gonna be easier too. One thing worth pointing out, in some cases tooling and errors in Haskell are not beginner friendly at all, which requires additional learning and perseverance. You need to know category theory. There are a lot of Haskell tutorials that explain things in terms of category theory, which can give a wrong impression that category theory is fundamental for Haskell, especially when people bring up the category of Hask. Well, compiler GHC developers, which is the main Haskell compiler, don't consult with category theory when developing. Most of the library developers too, and especially regular developers. Category theory is quite abstract, but also it's pretty neat and exciting. Category theory raises many interesting questions or discussions. For some it can be a helpful framework for thinking about software, logic and the relationship between different objects. For others, it's useless and overcomplicated. Do you need category theory to write Haskell or use libraries? No. Is category theory useful? Yes. And is it nice that there are a lot of intelligent people who do understand category theory and write valuable libraries so I don't have to? Yes. Which brings us to monads and the idea that you have to learn about monads as soon as possible. Well, this is more of a legend than a myth, so I'll keep it short. Monads is yet another pattern. There is nothing magical about it. Somehow nobody ever says, I want to learn Java, what is visitor or abstract factory, or I want to learn Ruby, what is MVC. After you learn and use a language for a bit, you can start recognizing and using patterns. Yes, you can use Haskell without knowing monads. You may have to relearn the same things when you try to use different language constructs, but this is what people do in every programming language. First, learn the basics of the language, learn how to use lists, optional values, async, await, etc. And then, in case of Haskell, eventually see the patterns. And when it clicks, you can use the same tools and syntax to solve various problems, old and new. For example, this is how you can loop over 2 collections in Haskell. Or this is how you can get 2 optional values in Haskell. This is how you wait till the service is ready and then do the work in Haskell. Or in case of other languages, use different constructs for different things. This is how you loop over 2 collections. This is how you get 2 optional values. And this is how you wait till the service is ready and then do the work. You can't do anything useful because there are no side effects. This is a widespread misconception. Some tutorials make it seem like Haskell is quite limited. It can't interact with the outside world or be used with anything that has a state. For instance, we can't even fetch data from another service, which is silly. This is not true, but it still draws people away from Haskell without even trying it. Here's an example of the program that reads from the standard input and prints into the standard output. If we run it and input a text like J, it prints J has just interacted with a Haskell program. I hope this showed that the myth is just a myth. The thing is that pure functional programmers have a different definition for the side effects from the mainstream. That's why saying there are no side effects in Haskell does not mean that there is no input-output in Haskell, or there is no interaction with the outside world. Long story short, there is a difference between evaluating and reasoning about program without side effects and executing this code which has side effects. If you want a proper, longer explanation, check out referential transparency. I have a separate video and article on this topic. Haskell is not suitable for web development. Building on the previous misconception, Haskell is sometimes perceived as unsuitable for web development. Somehow, Haskell is perfect for writing compilers and nothing else. Well, it is perfect for writing compilers, but what makes it perfect for this task makes it pretty good for others. Haskell features and libraries allow us to write maintainable and robust code and eliminate a large variety of bugs at compile time. For example, Haskell encourages modeling the business domain and making all the assumptions explicit. On top of that, Haskell has several frameworks and libraries for building high-performance and scalable web applications. For example, IHP, which is Battery Included Web Framework, or YSOD Web Framework, or even something like Servant, which is a library that allows representing a web API as a Haskell type. Which means that you can check if your server, client, or even both implementation respect the API specification at compile time. There are also about a dozen Postgres libraries, all levels of abstraction from writing low-level queries up to the type level. So you're totally covered. And it's not just web development. Haskell is general-purpose language, which means you can do anything. Well, maybe not embedded or system programming. In these cases, you should probably use something like Zig or Rust. If you want a detailed overview, check out the state of the Haskell ecosystem. There are no libraries. When it comes to library availabilities, yeah, some domains are less mature than others, but it's not that dramatic. Yes, if you ask a Haskell developer if you should purely use Haskell for your production machine learning pipeline, they will probably tell you no. But it doesn't mean that you cannot do it at all. The same state of Haskell ecosystem showcases some available libraries per domain. In this case, there are Haskell libraries, as well as bridges and integrations for other ecosystems. So it's doable depending on the task. Haskell has a smaller ecosystem than mainstream languages. Therefore, there are fewer libraries and tools available, and you might need to write more code from scratch. It hurts the most when it comes to integration with other teams. While they can just plug and play pretty much any new fancy technology out of the box, we have to write some things from scratch or tweak it around to suit our needs. There is also this idea that there is this big tooling issue in Haskell. Maybe it was true back in the day, but it's definitely not true anymore. Long story short, you install one tool, GHCApp, your favorite editor, and have all auto-completion, go-to definitions, auto-imports, and whatever you need. On top of that, Haskell has some special toolings that other languages can only dream about. And of course, there are issues here and there, but we as software engineers, we know how it is. And if you're curious, I've covered this topic separately. Performance is very bad. Haskell is often perceived as being slow compared to other programming languages, but this is not generally true. Haskell's performance can be on par or even faster in some cases. GHC generates optimized native executables. The runtime system supports green threads. So Haskell is an excellent choice for high-load concurrent applications like web backends. I've primarily worked as a web development, so I'm definitely the last person you should ask about real high-performance applications. Some people care about performance. They share their experience and actual numbers. I'm going to link the recent Reddit discussion as an example. On a related note, is Haskell compilation slow? Well, yes, because it's doing lots of work for us. Personally, I don't mind waiting a couple of extra seconds instead of spending hours of debugging some runtime errors afterwards. And it's just like with other compilers. Rust, for instance, nothing comes for free. Quick reminder, you don't have to fight the compiler. A compiler is your friend and here to help. Toxic ivory-tower community. Not gonna lie, unfortunately this is somewhat true. You don't have to look very hard to bump into a rude, opinionated person who is happy to tell you how wrong you are. For instance, if you apply that some learning method does not work for you, at least one person will happily tell you that you are wrong about yourself and your feelings. It doesn't mean that the whole community is like that. It's just people like that are often the loudest. If you're lost and have questions, you will get an answer. There are a lot of nice and welcoming people in the community. Check out what Simon Peter-Jones loves about the Haskell community. The problem is that you either have to learn how to filter these other people out or take some time to find some smaller sub-community. For example, you can find a cozy Discord server. So yeah, if you want to hear that, well, technically you are wrong about something, you're welcome. But if you're looking for friendly references or links that I mentioned during the videos, you can find them in the description, which is a fact. and tune in next time when I'm gonna be complaining about people who complain about syntax.